Good day. In this video, we're going to look at a chart from last year and a chart that's new to the course this year. This is the solubility chart, and by soluble, it means they're soluble to an extent of at least 0.1 moles per liter at 25 degrees for any given ionic compound. So if you have an alkali metal, and they're spelled out here, they're going to be soluble. Same for hydrogen, same for ammonium. So that's talking about positive ions or cations. Nitrates are always soluble, doesn't matter what the positive ion. Chloride, bromide, iodide, these halides are soluble with most positive ions, only insoluble with those three. And you just see it carries on. And then you get interesting patterns like strontium with sulfate will make a precipitate, but strontium with sulfide will be soluble. So these are things you should recall from last year. We used them to figure out net ionic equations, and we also used them in qualitative analysis, selectively precipitating out ions. We use them again this year when we're looking at compounds and different types of questions to see if things are soluble or not. What's new for us is another kind of equilibrium constant. So this says Ksp. Sp for solubility product. Our last section we always went Kq for equilibrium constant. But these are equilibrium constants for assorted ionic compounds. So if a question doesn't give you a Ksp value, you come to this chart and you look it up. And from a Ksp value, you can actually calculate a solubility for any of these beasties. You can see some numbers are incredibly tiny, like the iron 3 hydroxide, 10 to minus 39. And some are moderately soluble. 10 to minus 7 is not too bad. 10 to minus 5, minus 6, that kind of thing. For something that's not soluble, it's pretty soluble for not soluble. How's that for mumbo jumbo? But anyways, get used to using this chart. Make sure you understand that it's telling you about Ksp, so you could figure out a solubility. You will also use these Ksp values in doing what are called trial ion product questions, where you're trying to figure out if a precipitate forms. So that's a reminder or review, overshot, of the solubility chart and of your new Ksp chart. If you're doing a textbook question, it will have Ksps and it may have it for other compounds, but these will be at the back of the book as well, and for textbook questions, use the chart at the back of the book.